First, let's review the concepts of interaction and confounding. Interaction, also known as effect measure modification, is a natural finding that needs to be reported, and it's not a bias that needs to be avoided. It's just how things are. For example, you might have response to therapy or screening that may vary in different groups of strata because they have a different risk. Confounding, on the other hand, is a bias that the investigator hopes to remove. This is an extraneous factor that may partially or completely account for the effect that we see between an exposure and an outcome. There are three main questions you want to ask every time you start an analysis. The first question is whether the data are independent or not. If the data are independent, then we can run the traditional analysis. If the data are not independent, then we need to do some correlated data analysis, and we will see some of it toward the end of the course. However, matching is also a type of correlation. For example, our two eyes are correlated or matched. The next question you want to ask is whether there is an interaction. If there is an interaction, then you want to report the stratum-specific results. If there is no interaction, then you can go ahead and check for confounding. For example, if gender is an effect modifier, then you would want to report the results separately for males and females. If there is no interaction, you check for confounding. And if there is confounding, then you want to report the adjusted estimate, for example, an adjusted odds ratio. If there is no confounding, then you can just report the crude estimate, like a crude odds ratio or crude risk ratio. Let's take a look at an example. For example, here we have screening at the population level for abdominal aortic aneurysm. The aorta is a large vessel that carries blood to your heart. In some individuals, the aorta may balloon and actually rupture, so these individuals are ticking time bombs. These individuals do not know that they have an aneurysm, so you need to decide whether you want to screen or not for this condition. If a person is not screened and the aneurysm ruptures, then the risk of death is very high. And the higher mortality for women versus men during the elective surgery to repair the aneurysm. So we have to decide whether it's good to screen individuals and then conduct an elective surgery, or just watch the aneurysm or do no screening at all. Because of these gender differences, should women be screened or not, and what about men? So you might want to look at the two strata separately, given that their risk of aneurysm and also the risk of mortality during the elective surgery are different. So you may see screening advice from the US Preventive Service Task Force. In this case, they've actually stratified individuals based on their gender and age and whether they smoked or not, and also whether they have a family history. So because the risk is different based on these conditions, then the screening is also applied differently. So there is a real difference between these groups. And this is not something you want to adjust away, like if it was a confounding, but you want to be aware of and then take that into account. And so you would not recommend overall screening for everybody, but it would depend on the risk. In addition to effect measure modification, you also want to consider confounding. There are techniques you can use to control for confounders, both at the design and the analysis stage. During the design, you could restrict, for example, you could just select females. You can also randomize, and you can match. However, matching doesn't always control for confounders. It depends on the type of design. You can also control for confounders during the analysis by stratifying, conducting a regression or modeling, or standardizing. You probably have heard the matching is used to control for confounding, but is it always true? And if you decide to match, how do you analyze the match data? What's the difference between stratification and a matched analysis? We will take a look at all of these.